Hello colleagues, welcome back to my YouTube channel. Today, we're going to explore a fascinating phenomenon that affects the very fabric of our power transmission systems. Imagine a silent and invisible phenomenon that can drain energy, disrupt operations, and even threaten the reliability of our electrical grids. The corona discharge, the unseen enemy of transmission lines. Please, if you're new to my YouTube channel, support the channel by liking and subscribing to the channel. Hit the notification button to get notified whenever I post important tutorial like this. Corona discharge is a complex and intriguing topic that has puzzled engineers and scientists for decades. It's a phenomenon that occurs when the air around transmission lines becomes electrically charged, creating a conductive pathway for energy to escape. But how does this happen? In this video, we'll take a deep dive into the world of corona discharge, exploring its causes and consequences. Stay tuned. Welcome back. The term corona effect, also known as corona discharge. So, what is corona discharge? Corona discharge is an electrical phenomenon that occurs when a high voltage is applied to a conductor, such as a transmission line, causing the air around it to become ionized. This creates a conductive pathway for energy to escape, resulting in a faint violet glow, hissing sound, and production of ozone gas. If this sounds a bit mysterious, no need to worry. Let's take a closer look and break it down together. Take a few minutes and observe this corona discharge with hissing sound. You might have observed something notable about this phenomenon within this few seconds. Now, how does this mysterious phenomenon occur? A transmission line, consisting of a bare conductor, it uses the air around it as an insulator. The air is composed of atoms, each containing electrons that are tightly bound to their orbits, making them good insulators for transmission lines. However, when a high voltage current flows through the transmission line, the air near the line is subjected to intense energy, creating an electric field around the line. As the electric field strengthens, the insulation properties of the air is gradually weakened, reducing its ability to withstand the electrical stress. As the electric field continues to build up, the potential difference between the transmission line and the air increases continuously. However, when this voltage exceeds the critical disruptive voltage, the insulation strength of the air is broken down, and the free electrons of the air molecules near the transmission line become ionized, emitting a faint violet glow known as corona. This phenomenon appears around the conductor. At this point, the potential gradient between the transmission line and the air is 30 kV per centimeter at the conductor surface. As the potential difference continues to increase, further ionization will occur, making the corona discharge visible to the human eye. This increased voltage is referred to as the visual critical voltage, marking the point at which the corona discharge becomes visible. The visible effects of corona discharge include the following characteristics. 1. A visible faint violet light around the conductor. 2. A hissing or crackling noise. 3. Production of ozone gas. Now that we've covered the basics of corona discharge, let's break down some key terminology related to this electrical phenomenon. 1. Critical disruptive voltage. Critical disruptive voltage is the minimum voltage at which corona discharge occurs. It is the voltage at which the electric field strength is sufficient to ionize the air or gas surrounding the conductor, resulting in a corona discharge. Below this voltage, corona discharge does not occur. 2. Visual critical voltage. The visual critical voltage is the voltage at which the corona discharge becomes visible to the human eye. It is the minimum voltage required to create a visible plasma. The visual critical voltage is typically lower than the disruptive voltage. Now, you might be curious about why ionized gases or air around the line produces a bright light. Let's break it down. This is a fundamental concept in chemistry and physics. When gases are ionized, they emit light mainly due to electrons and ions recombining, as well as the excitement of atoms. Here is what happened. When the air surrounding a transmission line is exposed to a strong electric field, electrons gain enough energy to break free from atoms, resulting in the formation of free electrons and positively charged ions. These high-energy electrons are unstable and cannot remain in their excited states for long. Eventually, they return to their original, or lower energy levels, releasing the extra energy as light. The color of the emitted light depends on the energy difference between the excited and lower states. Different gases emit different colors when ionized because each gas has a unique atomic or molecular energy structure. In the case of corona discharge around transmission lines, ozone gas is often involved, which emits a faint violet glow when ionized. I hope this clears up your confusion and enhances your understanding. Having discussed the concepts of corona discharge, let us explore the benefits of corona discharge. Here are some advantages of corona discharge in transmission lines. 1. Virtual diameter increased. Corona formation increases the conductor's effective diameter by making the surrounding air conductive. This increased diameter reduces electrostatic stress between conductors. 2. Fault detection. Corona discharge can indicate potential issues with transmission lines, such as insulation damage or contamination, allowing for prompt maintenance and repair. 3. Condition monitoring. Corona discharge can be used as a diagnostic tool to monitor the condition of transmission lines and identify potential problems before they become major issues. 4. Insulation testing. Corona discharge can be used to test the integrity of insulation on transmission lines, helping to identify areas where maintenance or repair is needed. These advantages can help utilities and transmission line operators improve the reliability, safety, and efficiency of their transmission lines. Now, here are the basic key points to note about corona discharge. 1. Corona discharge is due to insulation strength breakdown of air around the transmission lines. 2. Corona discharge does not occur in low voltage lines, but in high voltage transmission lines. 3. Before corona discharge occur, the potential difference at 1 cm away from the line must be 30 kV. 4. Visual critical voltage is typically higher than critical disruptive voltage, as it requires a higher voltage to produce a visible discharge. 5. The air possesses electrical properties at high voltage. Now, are you curious about the downsides of corona discharge? The answer is yes, it is disadvantageous. But what factors contribute to occurrence of corona discharge, and how can we mitigate its impact on transmission lines? For the answers to these questions and more, check out my follow-up video on corona discharge. As a high-voltage engineer, linesman, or power system technician, this video is a must-watch. You will gain valuable insights into corona discharge and learn how to mitigate its effects. The link is in the description box below. In conclusion, Corona discharge is a result of the interaction between the electric field surrounding the conductor and the air molecules around it. When the voltage on the conductor exceeds a certain threshold, the electric field becomes strong enough to ionize the air molecules, creating a plasma. The resulting effect, primarily observed in overhead lines near insulators, is marked by a bluish-violet glow. That's all for today's session. If you found this video helpful, please support my channel by giving it a like and subscribing for more content. Bye for now.